This is why you need UVMLint. Ever struggled with UVM verification? We've got a game changer for you. Today we're thrilled to introduce an expert who's been revolutionizing UVM verification right here in sunny San Diego. With over a decade of experience in hardware verification and software development, she's seen it all. Every challenge, every workaround, and now, every solution. Meet Hema Hernandez, a senior verification engineer who has seamlessly integrated UVMLint into her workflow, transforming how verification is done. AsFigo's UVMLint is not just another tool, it's the tool that makes UVM verification faster, smarter, and more efficient. Hema has been at the forefront of this tech wave, leveraging UVMLint to tackle complex verification challenges, streamline processes, and boost productivity. She's here to share her invaluable insights, real-world experiences, and tips on how UVMLint can make a difference in your projects too. So if you're tired of wrestling with verification headaches and ready to up your game, stay tuned. Hema will guide you through the ins and outs of UVMLint, showing you how this innovative tool can elevate your verification processes. Ready to unlock the full potential of UVM verification? Let's dive in with Hema Hernandez and discover how UVMLint can transform your tech journey. Don't forget to like, subscribe, and hit the notification bell for more tech insights and updates from AsFigo. Let's get started.
UVMLint, which is a BYOL. So what is BYOL? It's called the Build Your Own Linter. So a build your own linter means we have a UVMLint, which we will have a minimalistic set or a basic set of rules, and then we can build our own lint. So we will see more details in the upcoming slides. So this is a UVM system Verilog linter. Okay, now why do we need UVM linting? Let's understand that in the first place. So we all know that for any RTL design, right, and even the software domain, there has been a linting or a rule checking always. This has been there for a while. This is to maintain a very high quality code and also for the effective functional implementation, silicon implementation, right? Now, but as opposed to that, with regard to the UVM and system Verilog, we do not have this advantage. We do not have, this is supposed to be one of the leading verification language, but we do not have this, we did not, rather, I wouldn't say we do not, sorry for that. We did not have this linting. This is also because, the EDA tools and the commercial factors in developing such tools in the past. So in the past, we did not have this. Now, with the current experience in building and deploying lint tools based on so what we are done, now we have the capability of building such tools. When I say such tools, linters, which is based on a open source platform called SLang and PySlang. SLang is system Verilog language and PySlang is, since it's based on Python, it is developed, the rule set is developed in Python. It's called the Python system Verilog language. This reason of Python is because it's very easy to, integrate or customize with reasonable cost. That is, when I say customize, we'll have a basic set of rules and we can build our own rules, and at a reasonable cost, pretty low cost. And we also share how such can be integrated into the CI/CD, that is the continuous integration and development flow, such as this Git actions, right? Now, so as you see it, the front-end engineers, again, the verification engineers, so-called, or the front-end RTL engineers, they use the lint-based rule checking to maintain high quality and predefined coding rules. While the linting, also the linting is available for the synthesizable code. So you have linting for RTL. You also have linting for synthesizable code. And the verification counterpart did not have. We are lacking in the past, but now there is a necessity, and we have come up with this TB or the verification linting, UVM linting, and since it was not there earlier, we used to see a lot of errors and long simulation time. And to avoid all that, we are coming up with so there was no standard rule or policies for the coding guidelines. So, based on the UVM and picking important ones, in the past, there was no easy way of adhering to these rules and flagging any potential violations. Thereby, it used to affect the usability, reusability, quality. Now, we are intended to change that. That is what this UVMLint is about. So, what we saw in this was that we do have RTL linting, we do have synthesizable code linting, but with respect to the UVM linting, we did not have it in the past. And currently we have and the reason being even the EDA solutions and cost was the main factor. So now we are able to, with available guidelines and things like that, we are able to do the TB linting and also integration to the CI/CD flow and at a reasonable cost. Now, what is the solution for that? The open source. Open source comes to this rescue, and open source is because it is scalable. When you say scalable, it is actually that you can build it as you go. That is, we have a minimum set, and then we build as we can as we move on. Like it depends on the requirement. We could build rules for performance, rules for speed, etc. So, like the EDA tools, it's not just one tool. In EDA tool, we all know, and here again, it's nothing about when we are saying EDA tool, it's nothing about to complain or to say that EDA tool has its own best of the features. But this is what we are talking here is the open source tools. The reason is here the license. It is not when you say open source, it's not a licensed tool. Also, the building everything, the cost wise, it is reasonable. Also, there is a shift left in the timings where you can achieve it at a faster pace. And like EDA mindset, we do not have one linter that I give you and say, go and use it for all your requirements. Here, it's not true. We give you a set of rules, but we say that you want to build your own rules. Yes, our team is available to do that for you. Now, we also build the missing pieces here. Also, we said it's also a proven CI/CD flow integration practice. It is the one more thing advantage of open source is a large skill force, right? Large number of engineers, maybe in a bigger company for a bigger project. When we are doing it, the licenses are limited. With the open source, what you can do is most of it you can run it in the open source, and then as a sign off, you can use the EDA vendor tools. Because when I say sign off, because it is proven, that's why. Even this is being proven as we speak. So what is BYOL? We said BYOL is build your own linter. It is an open source which can lead for the commercial tools to flow. Here, two advantages, like I said. One is about faster turnaround time, and it is for a huge set of developers because we are not restricting, it's not licensed. So, a college intern kind of people, fresher graduates, all these people can use these tools to run the tool faster, where we save the time and also we save the cost because that many licenses or the licenses are not even required for this purpose. It's an open tool. And we say invite to innovate. That is, this is not restricted. Say a group of people, it's not just about AsFigo or VerifWorks. AsFigo and VerifWorks have pioneered in this BYOL. That is, we are the pioneers in, we are the number one or running ahead of other people. But that doesn't mean others cannot join. We encourage a lot of the partners, the other engineers who are interested to join this and help us write the rule, run it, and ensure that it is working. It's not just about using a rule, it's also about innovating and writing the rule in Python. Now let's straight away get into the things that the UVM rules that we said. Let's see what are the rules we can identify as of today. Now, UVMLint identified rules. Rule number one is that you need to check all the files for having include guards. So what is this include guards? Include guard is nothing but to prevent the same include file being compiled more than once. So there is an include file which you'll be using across the in the code. So in smaller designs, it doesn't matter because you might have one include file. But when it comes to bigger designs, like really big designs, real-time designs, real-time TB and DUT and things like that. So this include guard, the include thing will be repeated. So when you use include guard, then it prevents from compiling more than once. It helps avoiding the name clashes, also issues that can arise while copying and pasting the header files that we know. When you copy paste, you might leave a slash, you might leave a hash, you might leave a close bracket, some H may be missing, those kind of things. So that is the reason why we have this include guards. And here is a little code about the include guards, bus package SV, and then end if. Yeah, if and end if. In the rule number 2, it checks with class having files with class having include guards with unique names matching the class name. So that is also very important. So the rule number 1 talks about include guards. Rule number 2, we are saying it talks about class having include guards with unique names matching the class names. So it's a good practice to prefix depending on the project and the file, right? The file name should be based on the project. This ensures that no two files in the project or different projects will clash with each other in each other's include guard names. So you have an include guard name that you have specified. But what happens is by using a prefix, say for example, we are working on SVCK. So we say SVCK underscore, that package or something like that. Then what happens is that include guard is specific to SVCK. Now you do EL2, you would say EL2 underscore underscore something, right? So that is why so what happens, the rule number 2 checks that with class having include guards with unique names matching the class names. So far good. Any questions so far? Anything? Okay, I will take that as a positive thing and move forward. Now, in the UVM identified third rule number 3, what happens is check every other test bench file having we know this well, having if def with proper end of. Right, this is one of the good coding style again. So we have ash if def and ash end def. They are the preprocessor directives that can be used to conditionally compile portions of the code based on whether a macro is defined or not. This is useful in many situations, such as enabling or disabling certain path of the code based on specific condition or configuration, including for simulation, debugging, or different setup. If the endif is missing for one of the files, most EDA simulators point the issue only at the last compiled file, right? So this is the main thing here. This is what we don't want to see. When there are multiple files included and you're including, right, there should be an if def and an end if in every of that every code or where it ends, there should be an if def and end if thing. If not, what happens is your any of the EDA simulators, what it does is it will check for the last block or the last part of the code where it says that your endif is not there. But there would be codes which were in the body, I mean, in earlier to this, which maybe the EDA vendors does not, EDA tool does not flash. So that is what we are doing here. UVMLint will make sure that if one if def or if end def starts, it checks for end if to be present within that file. So if there are multiple files, it will check for each and every file. And it's not going to be that because it's like a nested file or nested this thing we say, right? So in that case, what happens is it might check for the last lines of code. But here we are making sure that it checks if there is a file, if and if diff, then if def, then there should be another end if for that particular code in that file. That's what we are talking here. It has a count mechanism to count the number of if def and if end def versus end if. Issue number 4 is that the HDL, UVM HDL force and HDL release and deposit, they must have fatal error on its failure. Currently, probably it was not there or it was not recognized. So while using this HDL force on using HDL deposit, UVM error or UVM fatal, to verify that force is happened or not. Else, we have to waste time in debugging. So force and deposit is majorly used during GLS and PAGLS simulation. Without a fatal error flag, force and deposit we get only at the long time simulation netlist failure. So again, if you don't have this UVM fatal error and UVM error, UVM deposit, UVM HDL force, then what happens? It is also during GLS, right? This is there, this is available, but without a fatal error being flagged, right? Force and deposit failures will get identified only at the long simulation netlist failure. So here's a little code for that wherein it uses the UVM HDL force. And then there is a UVM error, failed to force value. It says the value. Same way UVM HDL deposit, it says deposit on TBAB config fail. So it talks about these two things. Now about randomization. But the rule name or the rule, whatever is the rule, that is important. It's not about the number. Now, this rule is about randomization construct to have that fatal error when it is failing on its failure, right? So, what happens is it is often overlooked that fatal simulation problem is a system verilog randomization when there is a constraint conflict. So whenever there's a constraint conflict, there is a fatal error which is being overlooked. So if you try to randomize an object and it fails, by default, the simulator does not print any message because we said earlier that the fatal error as being overlooked. And the random variables retain because these are random variables, they retain their previous values. So you might send the same transaction values repeatedly without realizing it. So what happens is, since the failure has happened, there is a conflict. System verilog and for system verilog during the system verilog randomization, and because the simulator does not print any message, these variables retain their previous values. So we send the same transaction values repeatedly without realizing it. Some simulators have switched to stop simulation and create test cases. Always run with these. Now, check the result from the randomized function with an if statement. And so here what we are doing is we have to check the result from this randomized function with an if statement, and we should write a fatal error with a meaningful message. So what we understand here is that during this simulation, right, generally this error message is being ignored or overlooked. It's not ignored, it's overlooked. So the simulator does not print any message. So in this case, what we are doing is, so because of this linting rule, with this rule, what we are checking the result from the function, randomized function, with an if statement, and we write a fatal message with a meaningful message, fatal error with a meaningful message. And now that simple code for whatever we explained here is given here. And most of these codes are available in GitHub. You could go ahead and see it also. If it's not there, you can let us know and we can share it. So in the lint identified rule number 6, the UVM objections is confined to one level. So confine the UVM objections to basic tests. The primary let's understand the primary purpose of the UVM objection. It is to keep the task-based phases executing, such as it's a task-based execution, such as the run phase without an objection. And then UVM ends the phase at the end of the current time slot. Now, but if we excessively raise and drop the objections, we can use performance problems. We can cause the performance problems, which is a single well-planned objection works as well as dozens scattered ones. A test must raise an objection before starting a sequence to prevent the run phase from ending. It's already running, and if you don't raise an objection, the sequence it will keep running. So before starting a sequence, there must be an objection raised to prevent the run phase from ending. A scoreboard might raise an objection while waiting for the last transaction because it's a scoreboard. It will be waiting for the last. So please, but don't raise and drop objections inside a sequence as the test level one is already doing the job. One test level objection is enough to keep the phase running for the entire top level virtual sequence. So here what we are the objection, right? Do not have objections for every sequence that you're raising, right? What they are saying is that raise one test level objection to keep the running that keeps running the phase running for the entire top level virtual sequence and all its child and sequence and transactions. So by raising objections every time for starting of every sequence, then you're going to slow down the performance. That is what this rule is checking. So this is again one of the important. So see, most of the rules that we are checking, right? Although some could be, the styling guidelines, some could be the naming conventions, etc. But the rules that we are discussing today in these slides is mostly performance or, time only. Like, no, either, it should not be running for a long time, which is again a time issue, or performance, which is it should not slow down the process. So when it slow down, right, it definitely takes more time to run it. And then you cannot achieve a shift left there. In rule number 7, if the class name is the same as the checks if the class file name is the same as the class name. So in general, each class should be in its own file. There are two main reasons for this to keep each class in its for the readability purpose. I think we discussed about it. And also files remain a reasonable size. Navigation. If a class name matches its file name, its definition can be found intuitively. That is, that means you can grep it very easily because the file name, the class inside the file name and the class name, if they are same, grepping makes it very easy. There are several common patterns that lead to the exceptions to this policy. That means there are some exceptions in this case where the class file name is not the same as the class name, but we are planning to follow this. This is one of the rules that is being checked in the UVM linter. In the linter number 8, there are some UVM deprecated features. That is the features which are library and while because we are adding new features to the AP. These are some of the older features which are being deprecated. That is, they are not used anymore. We discussed about this UVM 1. We are aware, right? 1.2, 1.3, UVM 1800.2. This is a standard IEEE standard UVM. 1800.2. So when we move to the ITN, so basically there are features which are already there in the which are added to this API, which were working. But currently, we using deprecated features is discouraged because it marks all the usage of because again it slows down the process and it may not report as a warning or something. So these are some of the deprecated features. So if we understand correctly, the features that are there in the older UVM versions, they're being repeated, they're being deleted so that we use the newer features, which will help us in improvement of time. And time is money. So cost also will improve. Now UVM, the ninth rule is it is checking for the new usage and throw warnings. So this is also about the usage of the call factory create. So if you, I think if you read about it, right, for anything that you want to override, such as transactions and components, the power of UVM factory to make the test bench classes more configurable. The factory allows us to inject the new behavior into components while allowing them to make any changes to the class. When you need to construct an object, always call class type id create or the UVM create macro. Using factory to create UVM objects using the factory and components instead of allocating them directly allows this type of an object to be determined at runtime rather at compile time, hence to be overridden with the modifying requesting class. What is the basic use of this? It is for here the rule checks for new usage and it throws warnings. It increases the reusability of the verification components, right? And installation should take the form. So here's a code that explains how to do it. So the 10th rule would be for UVM constructor, use proper format. For UVM objects, the first argument of the constructor must be a string name. It must declare, the objects and components must declare an explicit constructor that follows a certain format. So for UVM object, the first argument of the constructor would be a string name, and all these arguments must be optional. For UVM components, the first two arguments of the constructor must be a string name, and UVM component are all additional arguments must be optional. So this is an example for this. So now check for proper usage of super, and this in the class scope. Calling super with the wrong function name. So checking for the check for the using super in functions. Super function name shall match with current scope. Calling this with the wrong function name, check for this using this in functions. This function name should be matched with the current scope. So this is basically proper usage of the certain things like super and in the class scope. So if you go ahead and do few examples, this will also be very well understood. Okay, we know about this config.db file for sharing variables in the environment. So we should check for the proper config.db file because it is something that we sharing the variables in the environment. When we need to access properties in the UVM base class, call the provided set and get methods of accelerating config files and virtual interface access with within sequence. Instead of accessing them directly using the DOT top NVSPI environment operator, if you could code calls these set and get methods, it stays independent of any specific implementation of UVM. Using dot operator to access a variable from different hierarchy of the UVM environment makes it hard to migrate the environment and hampers the reusability advantage of UVM. So here we need to use this config DB for sharing variables in the environment. But what happens is if you do not, it hampers the reusability advantage of. So our main thing for any UVM coding is we can reusable with all the background and things like that. So we can reusability becomes a major advantage. And if you do not use this uh, proper usage config DB, then we will have to check for this rule checks for that basically. No, yeah, then probably the last two. So in this case, it checks for class name matching the UVM macros argument. There are several UVM macros for which the first argument must be equivalent to the class. So like I said, some of the rules here are checking which may make a lot of sense in terms of repeated increasing your performance, not giving same kind of work, monotonous job, etc. But when you see the some of the rules here, right? Like I said, it is for the performance and parallelly for the when the performance increases and time decreases, obviously there is a shift left. But certain rules also checks for the things like whether the class name exists, whether you should prefix a name to have the same for similarity. These kind of things are also seen in the rules. So in this case, it is checking for the class name matching the UVM macro argument. Several UVM macros for the first argument must be equal to containing the class. These macros are UVM field utils begin, UVM sequence library utils, UVM add to sequence library, UVM set super type, register CB. This is class my UVM and he shows the code there. More or less the same thing, I think. It is about check for proper usage